Okay, so welcome to all of you. Today we will go to the next chapter, that is interpolation. So in interpolation, so first we will see what do we mean by interpolation. Okay, many functions may not be available explicitly. So explicitly means what? You cannot express x as a function of y or y is a function of f of x. We cannot express x in terms of y or y in terms of x. So if you express x in terms of y, then it is called explicit function. Or if you can express y in terms of function of x, then it will be the explicit function. If you cannot do like this, x in terms of y or y in terms of x, so that will be not an explicit function. Okay, so many functions may not be available explicitly, but the values of the function at a set of the points called nodes, tabular points, or pivotal points. Okay, then the finding value of the function at any non-tabular point. So that means what? Suppose we have the value of this one, f of 0, f of 1, f of 2, f of 3. The values are we have. The values are we have. So now here what? You can find f of 1.5 with the help of this given data. Okay. So that means what? Then finding the value of the function at any non-tabular point. So here what? So 0, 1, 2, 3 are the this is the nodes. They are called the nodes. Tabular point or pivotal point. This 0, 1, 2, 3 are. These are the functions value. Okay. So now we can find the value of f of 1.5. So f of 2.3, f of 2.1, 1.2, whatever this. Okay. 0.5, f of 0.5, something like this. Then finding the value of the function at any non-tabular point is called a interpolation. So that means what? Here the data is given f of 0 to f of 3. Then you can find the value of x which is lies between 0 and 3. We can find the value of any x which is lies between 0 and 3 with the help of this given data, and that is called a interpolation. Okay. So we consider the function y is equal to f is defined on the closed interval x naught x n we have given. So what will we divide this interval in n equal subintervals. Divide the interval this such as x naught or this. Okay. So now the interval is what? X naught x1, x1 x2, x2 x3, and so on. Okay. So the values of x being equal is placed like this. Xi is equal to, that means what here? X naught. So x naught. So x1 will be your x naught plus h. Your x1 will be your x2 will be x naught plus twice h, and so on and so on. So we are choosing this x1 x2 like this. Okay. So this is the relation of x1 and x0, x2 and x0, and so on. Okay. So that means what? X2 we can write x1 plus h, x2 we can write x1 plus h, and so on. Okay. So are called interval differencing. So whatever this h, so this is what h is interval differencing. So it is we are assuming that it is so obviously it is the constant. The values of f of x corresponding to the certain given values of x, x0, x1, x2, xn can be calculated and tabulated. That means what? Here we can write x, f of x. Here you can write x0, x1, x2, and so on. Here you can write the values of the function. Okay. So that means it is the tabulated. So this value is x0, y0, x1, y1, and so on. Okay. So now we are interested to find the finite differences. That means the forward differences. Okay. So finite differences. Finite differences. So first we will see the forward difference. Forward differences. Forward differences. So we will write the definition with forward difference operator. Okay. Or forward differences. Okay. Okay. So let f of x be a single valued. We need the single valued function. Single valued. That means what? We don't need the mod x now, because mod x is not a single valued function. So single valued function. Single valued function. Single valued function. And continued on closed interval x naught xn, then the differences f of x naught plus h minus f of x naught, f of x naught plus twice h minus f of x naught plus h dot dot dot, f of x naught plus nh minus f of x naught plus n minus 1 times h are called the forward differences, are called the forward differences, See what? F of x naught plus h minus f of x naught. This is. Then f of x naught plus twice h. Just we have done the previous one. So this is your function. This is your point. What? X naught plus h, x naught plus twice h, dot dot dot. And this is your function value. F of x naught plus h, f of x naught plus twice h, dot dot dot. So this minus this are nothing but this is it, f of x naught plus h minus this. Okay, the next one minus the previous one. Okay, so they are called the forward differences. And h is called interval differencing, and h is called interval differencing. Okay, the forward difference operator, these are denoted by so we'll write first general definition, f of x. This is the first, so this is the definition now, f of x plus h minus f of x. Remember this is the definition. Okay, so that means what here, delta f of x naught is what is here, just add h in the first one. So this is what, x naught plus h minus your function is as it is. Now this difference is nothing but f of x naught plus h. This is denoted by delta f of x naught. So similarly I can write this is what, x naught plus h, delta x naught plus h will be what is, you have to add in the add h, so it will be what, then twice h, then minus subtract this as it is now. This is what, x naught plus h now. Okay, now if you want to find this f of x naught plus twice h, what you have to do, you have to add h, so this is x naught plus 3h minus the function as it is now. This is x naught plus twice h, right? This is the first forward difference. This is what delta is called first, FIRST, first forward is called first forward difference operator. This is called first forward difference operator. Okay, so now we'll see how to operate the second forward difference operator. Okay, so now therefore what, delta f of x is equal to f of x plus h minus f of x. Remember this as a formula. Okay, so now del square is called second forward difference operator, and is defined as it is defined as del square f of x is nothing but del f of x, del f of x. So this is what then del of, what is this? F of x plus h minus f of x. Again you have to operate the forward. What you have to replace x by x plus h. In the first one, what you have to do? You have to replace x by x plus h. Replace x by x plus h. This will be what then? X plus twice h minus f of x plus h. Then minus. This will be as it is now. So this will be what then? F of x plus h minus f of x. Minus f of x. Right? So we simplify this. What we will get? This is f of x plus twice h minus f of x plus h. This is twice of, because x plus h minus, and minus will become plus. So this is f of x. So your del square f of x is this. Okay. So similarly with help of this one you can find a del cube also. So del cube f of x. How you can write this is what? Del square f of x. I know del square f of x. I can write this as what? Del of, this is what? F of x plus twice h minus 2 f of x plus h plus f of x. So what you have to do? First what? Replace x by x plus h. In the first bracket, what we do? We replace x by x plus h. So what we get? X plus 3h minus twice f of x plus twice h plus f of x plus h. Then you have to subtract this function as it is now. Okay, so f of x plus twice h minus 2 f of x plus h plus f of x. Okay, so now we will simplify this. What we get? F of x plus 3h. Now this is minus 2 f of x plus twice h, and this is minus f of x plus twice h. Will be the minus 3. Minus 3 f of x plus twice h. Now this is f of x plus h, and this is minus, minus become plus. Again this is what? 3 f of x plus h minus f of x. So this is what? Del cube f of x. Del cube f of x. Okay. So in this way, what? This is the first forward difference operator. We can operate like this. Okay. So now suppose your function is in terms of y0, y1 and so on. Suppose your function is like this. Suppose your y0 f of x0, y1 is same as f of x1, y2 is same as f of x2, and so on. Your yn is same as f of xn. Your yn is same as f of xn. Okay. Now we will find. So you cannot find the first forward difference of the delta. You cannot find delta y0. You cannot find delta y0. For what? For y0 there is no the term. So you can find delta y1. You have to find only delta y1. So delta y1 is what? y1 minus y0. Oh, this is delta y0. You can find delta y0. Okay, you can find delta y0 here. Delta y1 is what? y1 minus y0. So delta y1, delta y1. You have to add 1 here because your interval difference is 1. Your interval difference is 1. So here what? Okay. So this is what? For this you can, for y1, y2 you can write this what? For y2, this is not interval difference 1. For y2 minus y1. Okay. So delta y2 is same as what? y3 minus y2. So delta yn is same as yn plus 1 minus yn. Okay. So that means what? Delta yn minus 1 is same as yn minus 1. Okay. So this is the definition. Okay. So now delta square, delta yn is same as what? Yn is same as, so yn minus 1. Okay. So yn minus yn minus 1. Similarly, what? You can operate a delta square, delta cube, delta this, you can operate this. Okay. So therefore remember this, delta yn minus 1 is same as delta yn O naught delta y. So this is what yn minus yn minus 1. Or you just remember this is what in terms of yn also. This is what yn plus 1 minus y. Okay. You may remember this. Okay. Please remember this as a formula for forward difference. Okay. For forward difference. Okay, how you can find? Okay, so second we will do this. What? Second, this is second forward difference operator. This is second forward difference operator. So this is what delta y naught. So this is delta. What you have to do? You have to add 1 here. Then this is and minus, subtract this as it is. Then this will be what then? Add 1 here. So y2 minus y1 minus y1 minus y0. Okay. So how to operate first forward, second forward? This is second forward difference operator. Okay. So this will what then? y2 minus twice y1 plus y0. Okay. So this is your del square y0. If you want to find del cube y0, so this is what del of del square y0. Okay. So this is del of y2 minus twice y1 plus y0. If you forget, okay, so you may write this is what del cube y0. You del cube y0 is same as what del square del y0. Find del y0. Then this is what? Okay, so then this is what then del square y1 minus y0. Then this is what del of y1 minus y0. You can write this. You can find this one and then operate one by one. Okay, like this. Okay. So here what just I have calculated this. So I am using that one. Okay. So now what you have to add 1. You have to increase your suffix by 1. So this will what? y3 minus 2y2 plus y1 and you have to subtract this as it is now. This is y2 minus 2y1 plus y0. So this will what then? y3 minus 3y2 plus 3y1 minus y0. Okay. So in this way you can operate the first forward difference operator, second forward difference operator, third forward difference operator and so on. Okay. So this is just a definition of the operator now. Okay. So if the question asks like this, define the operator delta. So just define like this, any definition you can give. This is what? F of x plus h minus f of x. Or you may define like this, yn plus 1 minus y. You may define like this. Okay. So if they want in on f of x on suffix this, so you can apply both the formula. Both are the formula for forward difference operator. Okay. So now prove that yn is equal to 1 plus delta to the power n y0, where delta is a forward difference operator. Okay, solution. Now n is a natural number. N is a natural number. N is natural number. We will apply mathematical induction on n. Okay. So step 1. Let Pn denote the statement. Okay. So let yn is equal to 1 plus delta to the power n y0. Okay. So step 2. Step second. For n is equal to 1. For n is equal to 1. Okay. LHS is equal to 1. LHS is equal to y1. LHS is what? y1. So what is RHS then? RHS is equal to 1 plus delta y0. 1 plus delta y0. So this is what? y0 plus delta y0. So this is y0 plus y1 minus y0. So this is y1. Okay. So this is equal to LHS. This is equal to LHS. So therefore P1 is true. P1 is true. So for mathematical induction there are 4 steps. Okay. So step 1, P and D of the statement. Okay. And second one, verify the result for n is equal to 1. And step 3 is what? Assume the result for n is equal to k. And step 4 is what? Prove the result for n is equal to k plus 1. So step 3, assume that pk is true. Pk is true for some k belong to n, for some k belong to n. That is yk is equal to 1 plus delta to the power k y naught. For q y naught. Okay. So this is true. Okay. Step 4. We want to prove pk plus 1 is true. That is to prove that yk plus 1 is equal to 1 plus delta to the power k plus 1 y naught. Okay. So we say 1 plus okay, 1 plus delta to the power k plus 1 y naught. We will start from this and we will prove this is yk plus 1. Okay. We will prove this is yk plus 1. Okay. So this is same as what? 1 plus delta to the power k y naught. And we know this value. This will what? Yk. This will be yk. So this is what? 1 plus delta yk. So this will what then? Yk plus delta yk. Yk plus delta yk. And what is this? This is yk plus 1 minus yk, right? And this is what? Yk plus 1. This is yk plus 1. Okay. So therefore pk plus 1 is true. Therefore pk plus 1 is true. So therefore by principle of mathematical induction, Pn is true for all n belongs to n. Pn is true for all n belongs to n. Okay. So therefore yn is equal to 1 plus delta to the power n y naught. So we have proved this with the help of the mathematical induction. Okay. Now we take the next theorem. If delta is linear operator, then it satisfies, instead of linear we say this is forward difference operator, then it satisfies the following. 1. Delta f of x plus g of x is equal to delta f of x plus delta g of x. Second, delta c of f of x, so c delta f of x. And third one, delta to the power m delta to the power n f of x is same as delta to the power m plus n f of x. Okay. So for mn greater than 0, here what? C greater than 0. So we are not proving this. Okay. So remember this. So construct the forward difference table for for the following set of values of f of x is equal to x square plus x plus 1 for x is equal to -2, -1, 0, 1, 2. Okay, solution. Given that f of x is equal to x square plus x plus 1, x is equal to -2, -1, 0, 1, 2. See the interval difference. Interval difference is 1 now. So if x are equally spaced, then you can operate the forward difference operator. Okay, otherwise you cannot apply the forward difference. Okay, you cannot find a forward differences if x is not equally spaced. Now see here, all your x's are equally spaced. Okay, so we write table. You have to difference table. You have to write. So this will I write here f of x, and I will write here. I will write -2. So this will -1, 0, 1, and 2. Okay, I have to write the value of this one f of x. So this is what this is 4. 4 plus 1 is 5. 5 minus 2 is 3. This will be 3. So -1 square minus 1 square minus 1. This is what this will be 1. This will be 1. Then 0. This will be 1. Then it is 1. Then it is 3 now. This 4 plus 2 is 6, and then this is the 7 now. Okay. Now we have to write this is what delta f of x. First forward difference. What we have to do? This is what 1. This is 1. This is 1. Okay. So this is 1. So what we have to do? This minus this. So this will what then? -2. I write here -2. Then this minus this is 0. This minus this is 2. This minus this is 4. Okay. So what? The second minus first one, third minus the second one, and this. Okay. Now del square f of x. Del square f of x. So this will what then? 0 minus 2. This is 2. 2 minus 0. This is 4 minus 2 is 2. Is 2. Right. So del cube f of x. So this is what? 2. Then this is what? 2. This will be 2. Then 10 to the power 4 f of x is what? 0. So how many values are given? 1, 2, 3, 4, 5. If there are 5 values of the function, then you can go up to the 10 to the power 4. Your 10 to the power 5, 10 to the power 6 will be 0. So 10 to the power 4 will be the constant. This will be the constant. Okay. After that, all we are assuming that all are 0 now. 10 to the power 5. All higher order differences are 0 now. Okay. So this is the difference table now. So the question is what? Prepare the difference table. Just we have prepared the difference table. Okay. And from difference table, what is this? This is your what? This is your y0. This is your y1. This is your y2. This is your y3. This is your y4. This is your y4. Okay. So now this is your del y0. This is your del y1. This is your del y2. This is your del y3. Okay. This is your del square y0. In this, you are starting from what? Del square y0. Del square y1, and this is what? Del square y2. Right? So del cube y2, del cube y3, del square y3 is not there. It will be 0. Okay. Now here what? This is your del cube y1, y0, and this is what? Del cube y1. Del cube y2 will be 0. Del cube y2 will be 0. And this is what? Del to the power 4 y0. This is your del to the power 4 y0. Okay. Remember this. These are the differences of -2. At x is equal to -2. At x is equal to -1. At x is equal to 0. At x is equal to 1. And for x is equal to 2, we don't get. Okay. It will be 0. It will be 0. So this is what? This is what? At -2. This is what? Del square at minus the square at -2. This is at -1, and this is at 0 now. Okay. This is at this is the third difference at -2, and third difference at -1. For this one, there is no third differences. Okay, and the fourth difference at only -2. There is no fourth differences for this one. Okay, so remember this. Okay, remember this. This is your y naught. This is your del del y naught, del y1, del y, and so on. Okay. Find del e raised to ax. Second, del square e raised to ax. Third, del cube e raised to ax. E raised to ax. Okay, solution. Del e raised to ax. What you have to replace? You have to replace x as x plus h. So e raised to a x plus h. Replace x by x plus h minus, I will call this as 1. Okay, minus e raised to ax. So this is what e raised to ax into e raised to ah minus e raised to ax. So e raised to x is common. E raised to ah minus 1. Right. So now second, I have to find del square e raised to ax. So this is del of del e raised to ax. Right. So this is nothing but del of, we have del e to the power x. This is what? E raised to ah minus 1 e raised to ax. Right. So we have calculated this. Now e raised to ah minus 1 is independent of x. You can take the common. This is the rule of the constant. Right. You can take the common here. You can take the outside the operator now. This is e raised to ah. So for h, take the care. Minus 1. Okay. So delta e raised to ax. So this is what then e raised to ah minus 1. This is also the same thing now. E raised to ah minus 1 e raised to ax. So this will what then? E raised to ah minus 1 square e raised to ax. This is your del square. Okay. Now third, you have to find del cube e raised to ax now. So this is nothing but del of del square e raised to x, because what I have the second forward difference operator, second forward difference of e raised to ax. So I will apply that one. So this will what then? Delta del square is what? E raised to ah minus 1 bracket square e raised to ax. So this is what? E raised to ah minus 1 bracket square e raised to x. This will what then? E raised to ah minus 1 square, again e raised to ah minus 1 e raised to x. Right. So it will be e raised to ah minus 1 cube e raised to x. So this is the differences. Just we got this. Okay. So very easy. If you know the formula, you can easily find these values. Okay. So easily you can operate this one. So formula is known to, formula should be known to you. Okay. Now we take the next one. We take the next one. So evaluate delta tan inverse of x. Okay. So solution, delta tan inverse of x is equal to what? So tan inverse of x plus h minus tan inverse of x minus tan inverse of x. So you have the formula tan inverse of alpha. So this is what? Tan inverse of what? Tan inverse of alpha minus beta. Your alpha is what? X plus h minus x upon 1 plus x plus h into x. Okay. So this is what? Tan inverse of, if you simplify, this is h upon 1 plus x square plus xh or hx. This will be this. Okay. Okay. So you cannot do actually this one. So this is enough now. Okay. I hope that you understand how to operate first forward difference or second forward difference. Okay. So I think it is enough. So we can solve number of problems, try to solve the number of problems on the forward differences which are given in the exercise. Okay. So I hope that you understand this one. So in the next part we will see what is the forward difference now here. We will see the backward differences now in the next part. Okay. So now we will stop here. Thank you.